Right. So now, what is the next one? Series of functions. Again, here we need to verify whether it is uniformly convergent or not. So we will see the first problem in our tutorial sheet, right? That is, mm, determine whether each of the following series of functions uniformly convergent or not. A, that is series sin to the power of 4 times n pi x plus triple 9 over summation n is equals to 1 to infinity sin to the power of 4 times n pi x plus triple 9 over n square pi square. This is for all x belongs to real. So now we need to verify whether it is uniformly convergent or not. So you know that the majority of the series of tests we are going to verify with respect to the uh, Weierstrass M test, right? So here is first, what is the Weierstrass M test? If modulus of Fn of x is less than or equals to Mn, right? And the series is series of real numbers. If this Mn is convergent, right? This series is convergent, then the original series Fn, where n is equals to 1 to infinity, is convergent. That is Weierstrass M test, right? So here is what is the Fn of x, modulus of Fn of x. Is equals to, that is your, this is your sine to the power of 4 n pi x plus triple 9 over n square pi square. So we need to verify one by one. So we need to use the modulus triangular inequality mod A plus mod B. So here which is less than or equals to sine to the power of 4 n phi x plus triple 9 is a positive over n square pi square. But this value is less than 1. So this is less than 1 plus triple 9 over n square pi square. Right? So this is 1000 over n square pi square. This is your Mn. So what is your condition? If the series is a convergent, that is summation if n is equals to 1 to infinity 1000 over n square pi square. What is the series? Is it convergent or not? So take out the independent of n terms. That is 1000 is independent term over 5 square. Its summation n is equals to 1 to infinity 1 over n square. So what is this series? This is a P series. What is the P series? P series is 1 over n to the power of P is convergent. P is greater than 1. So here the P is equals to 2 and 2 is greater than 1. So this is convergent. So your Mn is convergent. Therefore, by Weierstrass test, the series is uniformly convergent. Right? Any doubt for this one? We'll see the second one, that is V. What is here? Summation n is equals to 1 to infinity 2 to the power of minus n x to the power of n over n cube plus n cos square of n minus x, right? For all x belongs to minus 2 comma 2. So what is the series? Whether it is uniformly convergent or not. Say we are going to verify the using the Mn test, right? So now we can call this value is Fn of x. So take modulus of Fn of x, that is modulus of 2 to the power of minus n x to the power of n over n cube plus n times cos square n minus x. What is this value? Here is n times cos square n minus x is there. We know that cos square n minus cos theta is less than 1. So we will see what is that one. Um, Here is n cube is there, right? So entire this value, that is, I can say uh, n cube, right? N times n, the denominator, right? This is especially this is greater than n because n times cos square n minus x is there, right? Okay, n times cos square n minus x is greater than n, right? Greater than n or the less than n. Cos theta is less than or equals to mod cos theta is less than or equals to 1. So n times cos theta is less than or equals to n, right? So n cube, you can say this one as a theta, right? So n cube plus n cos theta is uh, n cube plus that is less than or equals to n cube plus n, right? Is it correct? Yeah. N cube plus n cos theta. Mm, then is something wrong. So square, right? What is cos theta? What you are going to use? Not proper way. We can say in different one. Hmm. Okay, right. So the what is the range of the cos theta? That is, we can say, you can say the range of the values -1 is less than or equals to cos theta is less than or equals to 1, whatever the theta. Then if you take the square, that is cos square theta is less than or equals to 1, all values, right? All values are less than or equals to n, right? So whatever that value is less than or equals to 1, the product, if you multiply with the n times, what is that value? So what I am going to say here, the n times cos square n minus x, right? Uh, which is n cube plus n, this value is greater than or equals to n cube. Because all values are cos theta is the range, cos square is less than or equals to 1, maximum 1, right? So then when we are adding n cube plus n times cos square n plus x is greater than n cube. Of course, n cube plus n, then n cube plus n is again greater than n cube plus n is greater than or equals to n cube. So what happened? 1 over n cube plus n cos square n minus x is less than or equals to 1 over n cube. So now I am going to take, right, the maximum value of x is plus 2, that is 2 to the power of minus n to the power of x is an increasing function. So you can replace x by 2, 2 to the power of n over n cube. right? So what happened? These two are 1, then that is equals to 1 over n. So this is your m, right? So what is the summation? Mn is equals to summation 1 over n. So again, by P series, right? So the series Mn is convergent. If it is Mn is convergent, then the series of functions is uniformly convergent by Weierstrass M test, right? That is the way of approach. The last one, it is little bit lengthy problem, right? What is the last one? This is a general by using the definition n is equals to 1 to infinity x square over 1 plus x square to the power of n. This is for all x belongs to 0 comma infinity, right? So what is the procedure we need to take? What is the series? If right, okay, no problem. Um, what is the problem here? Uh, we need to verify the uh, by definition, right? So we need to find out what is the partial subs. So here, Fn of x is equals to x square over 1 plus x square to the power of s for all x belongs to 0 comma. So now I am going to construct a partial sum, right? What is the partial sum? For each n belongs to natural number, Sn of x is equals to summation I is equals to 1 to n, or k, let us say k, fk of x. What is this one? This is summation k is equals to 1 to n. What is the fk? That is x square over 1 plus x square to the power of n. So k, right? So here is k is equals to 1 to n. What I am going to do, I need to run this summation from k is equals to 0 to n. So 0 to n. That's mean when it is a 0, there will be x square. So you can subtract 1 x square minus x square, right? So again, here the numerator is x square, which is independent of k. You can take out as a common, that is x square summation k is equals to 0 to n 1 over 1 plus x square to the power of n minus x square. What is this value? For all x, belongs to 0 comma infinity, right? So you have to check the what is the sum of the n terms. Of course, here from 0 to n means there are n plus 1 terms, right? What is the sum? You know that if this value is less than 1, it is easy for what is the geometric sum of the first n terms. right? So clearly the common ratio, what is that one? 1 plus x square is less than 1. If it is a less than 1, what is the sum? The sum is equals to 1 minus, let us say this is a, right? 1 minus a to the power of, here is n plus 1 over 1 minus a, right? So your a value is lies in between and 0 and 1, then this is equals to x square times the summation is, what is the summation? 1 minus a to the power of n plus 1, that is 1 over 1 plus x square, right? To the power of n plus 1 over 1 minus 1 plus x square, right? Again here minus x square, right? Then we have to simplify, isn't it? So what happened? This is the when we are calculating the denominator, 1 plus x square minus 1 over 1 plus x square. This is minus 1 over plus 1. We will get x plus x square by 1 plus. What happened? This will be going to up because here is n plus 1. When it is going up, that is x square times 1 plus x square minus 1 over 1 plus x square to the power of n plus 1. n 1 over 1 plus this will be cancelled. So we will get only n by the denominator x plus x square, right? Isn't it? This is minus uh, what happened? I can put into inside minus 1. I will take the x square as a comma, minus 1, right? So here, what happened? What type of terms will be cancelled here? Again, it is minus 1, right? When we are taking the minus 1, that is here is LCM. I am going to take LCM for this one. That is x square times 1 plus x square minus of 1 over 1 plus x square to the power of n minus uh, x plus x square over x plus x square. What happened here? Minus x square. So plus x minus x square cancel. So you will get what is the value? So here is uh, take x as a comma. Here x, if I am taking x into 1 plus x here, right? Here is again what happened? Minus x, uh, x plus x square, we will get only minus 1, right? So plus 1 is only available. So here is simply this x and the square will be cancelled. We will get x times 1 minus 1 plus x square to the power of n, right? Over 1 plus x, right? Isn't it? So you can take out uh, you can take out mm, uh, 1 plus x, because here is we take 1 plus x here. So x over 1 plus x times 1 minus 1 over 1 plus x square to the power of n. What happened as n tends to infinity? This is approaches to 0, because this is a less than 1 power n. As n tends to infinity, this value becomes 0. So we will get x over 1 plus x. So what we did, this Sn of x is approaches to S of x, that is x over 1 plus x as n tends to, isn't it? So this is your S of x, sum of that one. So what we got, our partial sum Sn of x is approaches to S of x, that is equals to x over 1 plus x, isn't it? Right. But there is one inequality, but here in our material, they are using the binomial theorem for x belongs to 0 comma infinity, or you can use, what is the binomial expansion? 1 plus to the power of n is equals to 1 plus nx plus nc2 x square plus and so on, x to the power of n. That value is simply 1 plus x to the power of n is greater than or equals to nx, right? Isn't it? That is, of course, it is strictly greater than, that is, nx is less than 1 plus x to the power of n, right? And then 1 over 1 plus x to the power of n is less than 1 over nx, isn't it? If you multiply with the numerator by x, x is a positive. That implies x over 1 plus x to the power of n is less than x over nx. X cancel, that is equals to 1 over n. So this x over 1 plus x to the power of n is less than 1 by n. So keep in your mind, this will be useful in later part. So now we are going to using the Weierstrass M test. So that is what we are going to do for each, MN test, not Weierstrass M test. We are going to use the MN test. For each n belongs to n, Mn is equals to supremum of modulus of Sn of x minus S of x, where x belongs to 0 comma, right? So that is the supremum of what is the Sn of x? We verified that one, x over 1 plus x times 1 minus 1 over 1 plus x square to the power of n, right? This is minus S of x. S of x, what we proved S of x, that is uh, x over 1 plus x, where x belongs to 0 comma, right? So here is x plus x over 1 plus 1x, 1 over 1 plus x, we can take out a common, right? Then what will happen? What is the value of that one? What is the modulus? Modulus. That is the supremum of x belongs to 0, comma infinity. What is this value? This is if I am taking a common, right? Uh, x over 1 plus x, because here is also there. What happened? 1 minus 1 plus x square to the power of n minus 1. This are cancelled. So that is supremum of x belongs to 0, comma infinity. What we got it? Of course, all values are positive, so you can remove the modulus business. So then you will get x over 1 plus x times, what about the value? 1 plus x square to the power of n. So what I need to uh, linking with uh, 1 plus x business, right? So here, since 1 plus x square value is greater than 1 plus x, any doubt, right? And 1 plus x is again greater than or equals to, or simply 1 over x is greater than x, right? Okay, so no need. So that is, you can take that one. So 1 over 1 plus x is a greater than 1 plus x mean 1 over 1 plus x square is less than, can say less than or equals to 1 over 1 plus x. So now I am replacing this one by 1 over 1 plus x to the power of n, right? So that is less than or equals to supremum, right? Because of this less than supremum, where supremum is taken on 0, comma infinity, x over 1 plus x times 1 over 1 plus x to the power of n. So again, what we need, what is the relation in between x and 1 plus x? Here, what I told here, 1 plus x is a greater than x, right? That is 1 over 1 plus x is less than okay, 1 plus x is a greater than 1. 1 over 1 plus x is less than 1. So I try to remove the denominator also 1 plus x, right? And that is a less than or equals to supremum of x belongs to 0, comma infinity. I can remove x over 1 plus x by x times 1 over 1 plus x to the power of n. That is a supremum of x over 1 plus x to the power of n, where x belongs to 0, comma infinity. Of course, 1 plus x is again 1 by n. So 1 plus x is uh, uh, whatever the value we already verified. What is we verified? 1 plus x to the power of n, x over 1 plus x to the power of n is less than 1 over n, right? So this is, you can say the supremum of 1 over n because of the, what we are using the here, here, by using the binomial expansion. So the finally supreme of 1 over n, where x belongs to 0, comma infinity. So there is no x. So simply that is 1 over n. So this is my mn. So 0 is less than mn, or less than or equals to mn is less than 1 over n. This tends to 0 as n tends to infinity. Therefore, mn tends to 0 as n tends to infinity. So, what is your conclusion? Your original series, right? That is your Fn, where n is equals to 1 to infinity, is uniformly convergent and converges to a function s of x is equals to 1 over 1 plus x. So this is the way of procedure to identify whether it is a uniformly convergent or not for the series of functions, right? So come on, tell me if you need any tutorial for the uh, metric space. I think, did you receive all people what he prepared the list of the questions, what I told? Metric space. Yeah, everyone is received. Who is that guy? That guy is
Can
sent
you
to.
repeat? Can you repeat what you said, Dr. Lal? Can you repeat?
No, what I explained in the class, the important mean the review questions in metric space, what I listed in the class, that guy, Muhammad, or what is his name? Muhammad? Muhammad is around?
Yes, sir.
Yeah, I think you sent to me that one.
Yeah, the questions and the list. Yeah.
Yeah, so did you circulated to everyone?
Yeah, I think I circulated it. I don't know if anybody else didn't get it.
So check with other people who are attend this today class. Ask anyone, did you receive that one? Kela, Casilo, Shamir, Ragunan, Shemvin, Harris, Tanisha, Patar. All you people are received that list of the metric space?
Yes, sir.
Okay. Right. So better to focus the open and closed sets part, because up to the end is a little bit high. So focus open and closed sets and metric space examples, and whatever the theorems in between up to closed sets, you can do that one. So you catch my point?
Yes, sir.
Yes, sir.